Let's talk about something you walk over every single day, probably without even thinking about it, the humble manhole cover. But you know what? Beneath that heavy chunk of cast iron, there is a whole hidden world of incredible complexity. And in this explainer, we are going to pull back that cover and see what's really going on down there. So, when you see one of these, what's the first thing that pops into your head? Probably sewers, right? Or maybe you think of a movie scene, with steam billowing out. Well, the reality is, most of the manholes you see have nothing to do with wastewater. They are gateways to something way more powerful, something absolutely essential to our modern lives. So, what is under that cover then? Well, it's not just some simple tunnel. Think of it more like a junction box, a critical node in this massive underground network that we all depend on literally every second of every single day. Yeah, we're talking about the electrical grid. These manholes give workers access to vaults that are just crammed with high voltage cables. The power for our homes, for hospitals, for businesses. It's the literal nerve center of the city, hidden just inches beneath our feet. Okay, so obviously you can't just stuff a bunch of high voltage cables into a concrete box and call it a day. That would be completely chaotic, not to mention incredibly dangerous. So this underground world, it's governed by a very strict set of rules, all designed to keep everything safe and working just right. And that rulebook is the National Electrical Code, or the NEC. This thing is the master guide for basically everything electrical in the US. And for our purposes today, it's kind of the hero of our story. It's the force that brings order and safety to this hidden world of electrical manholes. This brings us to a really fundamental question. If you're an engineer designing one of these vaults, how big does it actually need to be? Well, the NEC is pretty clever about this. Instead of giving you a fixed number, like it must be 10 feet long, it gives you a formula. And that formula is based on the actual work that needs to get done inside. So what's the most important factor in that calculation? You might be surprised. It's all about turning corners. Seriously, imagine trying to move a big, bulky sofa around a tight corner in a hallway. You need a lot of extra space to make that turn without scraping up the sofa or the wall, right? It's the exact same idea with these massive, really stiff electrical conduits. So the NEC breaks this down into two types of what they call poles. The first one, a straight pole, is super simple. The cables come in one side and go straight out the other. For that, the rule is the box has to be at least 8 times the diameter of the biggest conduit. But the much more common scenario is the angle pole, where those conduits have to make a turn. And that's where things get more complex and where the manhole needs to be a whole lot bigger. Okay, so how do you actually calculate the size for that critical angle pole? The formula in the NEC, that's Article 314.28, might look a little intimidating at first, but it's actually pretty straightforward. Here's how it works. First, you take the diameter of your single largest conduit and you multiply it by 6. Easy enough. Then, you just add the diameters of all the other conduits that are coming into that very same wall. That's it. That final number gives you the minimum length or width you need for that side of the box. Let's make this real. Using the example from our source, let's say you've got a 6-inch conduit that needs to make a turn, and it's right next to 3 other 6-inch conduits. Okay, so you follow the formula. You take the largest one, which is 6 inches, multiply it by 6. You get 36. Then you add the diameters of the other 3, that's 6 plus 6 plus 6, so 18. 36 plus 18 gives you a minimum dimension of 54 inches. And just like that abstract rule becomes a very concrete number. And that number is what gives workers just enough room to safely pull and bend those heavy, rigid cables without damaging them. Because believe me, damage to one of those could cause an outage for an entire city block. But not every underground electrical box is one of these giant walk-in manholes. The NEC actually makes a really important distinction for the smaller enclosures, and they have a totally different name. Meet the handhole. The key difference is right there in the name. A manhole has to be large enough for a person, a worker, to physically get inside and do complex work. A handhole, on the other hand, is smaller. It's just big enough for someone to reach their hands inside to pull cables, usually at simpler points in the system. And because of this, the NEC says handhole covers must require a special tool to open, which adds a really crucial layer of security for the public. Now, as important as all these sizing calculations are, they're honestly just one piece of a much, much larger engineering puzzle. Building a safe and durable underground vault involves a whole host of other critical things to think about. And I mean, there are so many other factors. You have to have proper drainage, because water damage could destroy thousands of dollars of equipment.
The structure itself has to be strong enough to withstand the constant weight of traffic rumbling over it. Inside, the cables need to be racked properly, because if you bend them too sharply, you can literally break the conductors inside. And of course, you have to have safe ladder access for the workers.
And this is where another rulebook actually enters the picture. For a lot of these structural issues, the NEC actually points to a different standard, the National Electrical Safety Code, or NSSC. The NSSC is the one that covers all the detailed requirements for things like structural strength, drainage, and ladder access. So the two codes, they really work together, hand in hand, to create a complete safety system. So the takeaway here is that this is a highly, highly regulated field. And for any of you engineers or electricians watching, this slide is your cheat sheet. These are the specific articles in the National Electrical Code that you'd need to reference in your designs and reports. From the pull calculations we talked about in 314.28 to the general rules for underground wiring, it's all codified to ensure safety and consistency across the board. So the next time you walk across a manhole cover, maybe you'll think about that complex, calculated, and highly regulated world of energy that's humming just below your feet. It's a really powerful reminder that our cities depend on these vast, invisible systems that are engineered with incredible precision. And it kind of leaves you wondering, what other hidden worlds are right under our noses, silently keeping everything running?